Oh, this is Mr. McMurray, and it is, well, actually, it's Saturday evening, but this is Monday morning for you. So, here we go. We are doing the slowing down, speeding up worksheet, or as it's officially known, the slowing down and speeding up, because this letter, this thing right here is actually an S, okay? More about that here in a minute. But purpose of this worksheet is to be able to identify graphs. We've already talked about this a little bit when we did our graphing thing. If you have not turned in your graphing worksheet from the lab we did where we ran the 50-yard dashes on the field, 3 on one side and 2 on the other, you need to get that done and turn it in as soon as possible. All right. So, anyhow, getting on to this worksheet. One of the things we talked about last time was that if you look at a graph and if it looks like the bottom part of the S, it's curving up like that. It's getting steeper and steeper as it curves up. That's speeding up, okay, on a distance time graph, okay? We said distance is the rise or the y-axis, and time is on the x-axis, which is the run, okay? So rise over run, all right? Rise over run gives you the slope of the line, okay? We'll talk more about that minute. So basically, distance over time is rise over run, and basically tells you the slope of the line. So d over t is also speed. So speed is equal to the slope, and we'll talk about what that means here in a minute. All right. Now, on this, you notice like that's speeding up. Now, if it looks more like this way, where it's flattening out at the top, then that is slowing down. So let's look at the graph below and just see some of these things. Starting at the beginning right here. All right, once again, you see this little curve here? That's curved out, I guess, ring out like that. So that is more like the slowing down. So at this point in the graph, this person, vehicle, whatever, is slowing down, all right? And over here on the other side, we see going back up again, that's the steep one. So it's going to be speeding up, okay, just like we had up here, speeding up, curves like that. Curving over like this is slowing down, okay? Now, at the beginning, though, and here in the middle, we have a straight line. Okay, in this case, a straight line always means a constant speed. Okay, in other words, we're going at the same speed. It's not changing. We're not speeding up. We're not slowing down. We're going at a constant rate of speed. Okay, now, if you were to take a line on here, let me see if I can get a pen and work on this or not. Let's give it a shot. If you were to take a pen and move it over like here and do the rise over the run, and did the same thing up here, you would notice that they're going to be equal amounts, okay? The rise versus the run is the same, okay? However, if we have different lines that are both straight, like here and there, here, if we go a certain length of time here and then come up to see how much run we have, here, if we go over the same amount of rise, we're not going to have nearly as much run, okay? In other words, we've gone the same length of time, but we haven't gone as far, okay? So with a straight line, it means you're going at constant speed, but here's the deal. If they're both going constant speeds, but in this case over here on the left, it is steeper. Remember we said speed is the slope. So if the slope is greater and therefore it's steeper, then it's going faster. Okay, on the second line over here, which is flatter and therefore not as steep and therefore less slope, you are going slower. And slower in this case means you go less distance in the same amount of time. Okay, and so this one here is going to be flatter and therefore means it's going at a slower speed. All right, so here we have going at a constant speed, then they start to slow down. Now here we have a straight line going straight across. Well, if we look at this, if it's going straight across, time is still increasing, but the distance is not. So if the distance is not increasing, but the time is, that means you're not going anywhere. You're just sitting in one place still. So that means you are officially stopped. Okay, you're not going anywhere, so you are officially stopped. Now, it technically is still a constant speed, just like these ones over here. We said a straight line is a constant speed. So in that case, this is still true. It's just that now your constant speed is the speed of 0 and you are stopped. But you're going at a constant speed of 0. You're not speeding up. You're not slowing down. You're continuing to go at 0. Okay? And that's kind of the basic information that this graph tells you, and the distance time graph will show you. And this basic information should allow you to answer the worksheet. So we're going to put a pause on this. Let me get the worksheet out, and we will see how we can do the worksheet that you were so anxious to get started on, I'm sure. So I don't want to hold you up any more than necessary. So here, let's go to the worksheet. All right, here we are back again, and we are working on this worksheet here. Now, slowing down, speeding up, there we go, or lowering down, speeding up, worksheet, whatever you prefer to call it, there we go. Anyhow, we have the motion of 3 different graphs here. What I would like for you to do is write down here a brief description that tells what is happening and when, at what seconds on the graph is it happening, okay? And so, let's just kind of demonstrate here. So, first of all, if we look at the first part of the graph, we notice it's going up like this, and that is like the bottom part of our graph here, so we know it's speeding up, okay? Now, if you block this with a line or something like that, you would notice that it's going up until about right there, okay? That's kind of the dividing line. After that, then it begins to turn back the other direction, okay? And so very similar to our symbol here, but just more stretched out, it's doing the same thing, all right? So, down here under A, for the first description, we would go to write down what's happening, and we would say, so from 0 to 5 seconds. So we need to say when. Okay, so 0 to 5 seconds, what is happening? Well, basically, the person or car, vehicle, whatever this is speeding up. Okay, and we know that, okay, by the shape of it. Now, after that, it looks more like the other curve, at least until we get to, about right there, I would say. Okay, and so I would say from 6 seconds to 9 seconds. All right, from 6 seconds to 9 seconds, we are slowing down. All right, and then from 9 to 10 seconds, it is flat. And that means that we are stopped. Okay, and so that would tell us exactly what we did. From 0 to 5 seconds, we're speeding up. 6 to 9 seconds, we're slowing down. And then 9 to 10 seconds, we are stopped. Okay, so be as specific as you can where one thing stops and another begins. All right, and if you do the same thing for graph B and for graph C over here, and put those down here below. All right, now at the bottom, you're going to have to give me a little leeway here. My paper, when I saved it, has done some strange things on me. Hopefully yours did not. All right. It says, use the grids below. Well, you're going to have to look down here on mine. Yours should be right below there. Okay, and you're going to do a graph that does what it says is happening. Okay, graph D says an object travels at a constant speed for 3 seconds. Well, we know a constant speed is a straight line. So I'm going to start here, and from 0 seconds until 3 seconds, I am going to draw a straight line. Now, you have access to rulers, so use a ruler. Yeah, they're over there on the side. Go get one if you need it. But on the ruler, you're going to draw a straight line from 0 to 3. How steep is it? We don't know that. We just know it's a constant speed, okay? I would not make it really steep because it says you're going to speed up. So if you make it really steep, it's going to be hard to speed up much after that. Okay, now after that, then we know from there on in, for the next 5 seconds, it's going to be speeding up, which is going to be a curved up line like that. Okay, so this one should be straight. We're going to pretend it's straight. Okay, and then it should curve up out of control there. All right, then you will read E and finally F. Do those two on the 2 following graphs. All right. Now, the last thing is just another day at the Chihuahua races. Doesn't everybody like go Chihuahua races? Okay, maybe this Greyhound races. Anyhow, you should have our 2 Chihuahuas, Chihuahua number 1, Chihuahua number 2. Feel free to name them whatever you would like, but that's up to you. Okay, I'm just going to call them Chihuahua 1 and 2 so that I don't impede your creativity. Okay, so you can call them Jose, I don't care, whatever. All right, now, what we're going to do is we're going to look at these and see how we have drawn a graph here showing the race. All right, now in this one on color, we don't have a color printer, so you will notice that one is red and one is blue. Okay, the one in blue says Series 1, that's Chihuahua number 1. Okay, so when I talk about Chihuahua number 1, that's who I'm talking about. Chihuahua number 2 is going to be the redder one or lighter on your paper, a little more grayish color. All right, number 2. All right. So, basically, we're going to say, answer these questions using that information. For example, number 1, when was the first time that Chihuahua 1 had a faster average speed than Chihuahua 2? In other words, in order to have a faster speed, he had to have gone more distance in the same amount of time. And so if we look at this, you notice that they start off even here, but from the beginning, Chihuahua 2 is in the first place. So when is the first time that Chihuahua 1 is in first place? And the correct answer would be somewhere right in there. Okay, and so if we look at that, you can say that that would be at about, if this is 80, this is 80, 90, that's 85 right there. So it's a little bit before there. I would say about 82, 83, somewhere in there. That's about it. Okay. Okay, hang on. One last thing I should have done. Okay, first of all, this over here is, let me label the graph. I forgot we had not done this. The old graph I had did have, okay, so this is distance. Remember we said distance time graph, just like what we talked about earlier. Sorry, distance, and the distance are going to be in meters. Okay, and then down here at the bottom, this is going to be time. Oops, off there. There we go. Okay, time, and that is going to be in seconds. Okay, so we need to do that first. That makes more sense. Okay, so now this would be at 82 seconds is about when Chihuahua takes the lead. Okay, and it was at about 82-ish meters down the road too, but that's okay. All right, so that's not the issue. So it's what time did he do it? So the first time would be about 82 seconds or thereabouts. Okay, now number 2, at 0 seconds, when is either Chihuahua not moving? Well, to be not moving, you have to have a flat line from one dot to the next. So anywhere there's a flat line where they're not moving up or down, it's not going up, then we know that would be that. Okay, and the rest of them are going to be somewhat to that effect. Now, down here, this one, number 6, says, does Chihuahua 2 have a higher speed from 20 to 25 seconds or from 15 to 20 seconds? So from 15 to 20 or 20 to 25. Well, basically, we just got to look at that line from that time to that time and basically think in terms, is it flatter or is it steeper? Because we know the steeper the line, the faster he's going. All right, so you don't actually have to calculate that. You could calculate how far did they go, and it took them 5 seconds and calculate it, but you really don't have to. You just need to look at which one's steeper and which one is flat. Okay, now the next 3 here that are part of number 7 are going to be a little bit different. Okay, you've got from 90 to 95, so you're going to have to go up here at 90, figure out what the distance was, and then go to 95 and figure out what the distance is and estimate it. Notice it goes from like 60, 65, 70, 75, 80, like that. Should be able to estimate it pretty close. Subtract those two, see how much distance he's covered. Okay, and you know it's 5 seconds, so then divide that distance by 5 seconds, and that would give you your speed here. And you do the same thing from 65 to 105, subtract the two distances and divide by, it's like 40 seconds. And then for the whole race, how far did it travel, and so on. Okay? All right, so just remember, you need distance divided by time. So if you can calculate the distance, and then you can divide it by, whoops, that's not a very good D, but distance divided by time. Okay, so subtract how much distance they went in those areas, and then you'll be ready to go. All right, the last one's down here. Okay, for example, on this one, you're going to say a further distance or shorter. So further or shorter. If your speed increases, you're going faster, but you run for the same length of time. So if you're running you're going faster, but you run for the same length of time, you're going to end up going farther or shorter distance. And the correct answer is, that's right, further. You're going to go farther. Okay. All right, so we're going to put further or farther right there. Okay, oops, maybe not that. All right, then the same thing here. If you run for the same length of time, but your speed decreases, you would go a shorter distance. Okay, all right, oops, didn't click. All right, shorter distance. All right, so there we go, shorter. All right, I think I got a little carried away still on my farther, but we'll. One of those in a minute. All right, there we go. So now for this one here, it says it will take more time or less time. So you're going to put more or less, depending on what it says. I'll get more or less. And then down here, Would you be going faster or slower